Okay, welcome everyone to this continuation. This is what is tropical geometry. We are already at part 15, and I now want to make precise what tropicalization is. And I'm pretty sure, I never did that before, so let's try. If I Google tropicalization, I will find very strange things, or maybe not strange things. Actually, tropical geometry is a little bit strange, but I will not find tropical geometry type things. Apparently, West Tigers versus Raiders is a very popular search right now. Now I would just need to know what that actually means. Anyway, tropicalization. Let's see. Searching. Tropicalization refers to the process where species... Yeah, that's probably not related to tropical geometry. Yeah, probably not. What is the meaning of tropicalization? Warming climate. What does tropicalization mean? Maybe that's not quite what we are looking at. So it's actually good to introduce it formally. Kind of, again, tropical geometry is a slightly strange name. Okay, so is tropicalization. Tropical polynomial is that thing. Yeah, remember, it's this min of things, which is this piecewise linear function, right? I'm talking about the function right now, not necessarily the variety, which would just be that thing here, right? So the function itself. And the usual way we do this is we kind of look at the exponents, collect the exponents into this beast here. So 2 is now the main exponent here, 2 is another exponent here, and we tropicalize the polynomial, right? The tropical polynomial of that thing is that function. And the tropicalization should be essentially the process going from here to here, and not necessarily, well, this is also a tropicalization, but not the tropicalization I'm going to talk about here, right? So that's the whole point. And really, let's do it easy here. X squared plus 1. So the orange curve, right? This is x squared plus 1. Our little parabola, the orange curve, the piecewise linear function, is min 2x plus 1, 1. Exactly that thing here. So what happens here is that plus goes to min, and, well, times goes to plus, and this is essentially our tropicalization map. And we want to make that a little bit more general in the following sense. So a better way to say this is the following. Tropicalization, really, I hope this is reasonably clear at this point, is like taking a log, right? We are really interested in the exponents of something like x to the p. And how do you go to p if you have an x to the p? Well, you take a log, right? So log gets you to the exponent. And this is like little bit like taking evaluation. Essentially, evaluation is taking a log, right? In our power series ring here, the valuation is given by just looking at the lowest exponent, which is essentially just taking a log of the thing. So maybe what we should do is we should just put the valuation into our process of tropicalization. And that's exactly what we do. So we are given a valuation, like for this guy, we do it in a second together, and you take this polynomial again, and the tropicalization is you take the min, and you take the valuation of the coefficient, and you pull down, take this log thing here, you pull down the exponent into, well, this thing itself, right? You pull it down, so taking the log of this thing. So let's say a standard example that you could have is something like this. So here the coefficients are from this funny ring here, and these are the variables. So you would do a tropicalization here, take so x1 just becomes w1, x2 just becomes w2, x3 just becomes w3, just rename my variables. In this case, they don't have any powers, so they just appear with coefficient 1. And let's have a look at the whatever. This guy here, the only thing that remains is its power 4. This guy here, the only thing that remains is its power 2, because we're taking this log type. This thing here, the only thing that remains is its lowest power 1. And that is like the tropicalization of your polynomial, right? So for a given valuation, it's really taking a log, right? That's what we usually do in tropical geometry. Right? And why are we doing this? So tropical geometry, in some sense, came out of the study of Gröbner bases. We're going to recall what Gröbner bases are, but it's kind of a fun idea where I was really shocked when I first learned that, in the sense that I was like, why didn't anyone tell me about this before? Huh? So think about the following problem. You have a certain number, let's say whatever, a certain number of linear equations, and you want to solve them. And there's a standard algorithm to do that. You put it in your matrix and you do some Gaussian elimination process and you find the solutions. Everyone is happy. So you learn that in school, in linear algebra, you learn that very early on. Depending a little bit where you go to school, you should actually learn that in school. Cool. So the next step would be, well, you have equations, like two of them here, right? Two variables, x and y, and you have equations of polynomials, right? Polynomial equations, not necessarily linear, but maybe quadratic or cubic or something, and you have a system of them. So everyone likes system of linear equations, and now you have a system of polynomial equations, right? You want to find the common intersection of the green thing and the red thing. So there should be some algorithm who does that. Turns out you never learned it in school. You never learned it actually really anywhere, as far as I remember, when you study mathematics, even if you have it as a major or as a minor, it doesn't really matter. You somehow never learn it. And I was never really sure why, and eventually someone told me there's a theory of Gröbner bases, which is essentially designed to solve systems of polynomial equations. And tropical geometry plays a crucial role how to do this, and essentially was one of the reasons why it was developed. So system of linear equations, the well-known stuff. Maybe you've seen it in school, maybe you have seen it later, but I'm pretty sure you have seen it at one point in your life. System of polynomial equations, you want to solve them. For some reasons, you are somehow never told how that really goes. It is a bit tricky. It is a theory of Gröbner bases, but I still think it's worthwhile to know about it anyway. So we're going to zoom into Gröbner bases in the next videos, and it's really one of the main sources to play the process or play tropical geometry, where all of this kind of ideas of tropicalization will play a crucial role. Anyway, I hope you enjoyed this video, and I also hope to see you next time.